Okay, so now that we have effectively found the median, and you can see that I have gone through and I have made that mark on this particular site, we are at median is 7.5. And again, fun fact, guys, that median is also quartile 2. So we've already divided our quartiles into two, or our data set into two equal pieces. Where you see that yellow bar is quartile 2. So step 3 is going to ask you to look at the lower half or the lower quartile of your data and find the median there and mark it. So we don't want to look at any numbers that might be lying directly underneath this yellow bar. And I will show you an example like that. But we're looking only at the data points that are lower than this bar. So if this bar was on the 7, I would not include that 7 with finding the lower quartile. I can only use those data points that are on the outside or the left of this particular bar. So in this case, I can take a look at this and I'm going to draw a line to designate where that particular bar is. And it would be right here, right? If I eliminate 4 and 7, followed by 5 and 6, that gives me a bar right there. Oh, let me erase that. All right, so I've got my quartile 1, and if I had done all my math the same way that I did when I found my median, I would see that quartile 1 is 5.5 of my data set. Quartile 2, again, is 7.5. And next, I need to look at the upper half or the upper quartile of my data. Again, I'm only looking at the data that is outside or after this median. I won't include anything that's directly underneath it. To find that upper mark. And in this case, if I do some elimination, right, 8 eliminates 12, it's somewhere between 8 and 9. So again, here's my third quartile or quartile 3 for this particular set. Right, so quartile 1, 5.5, quartile 2, 7.5, and quartile 3 is 8.5. All I've done at this point is I've taken my data and I've divided it equally into 4. Now, if we look between each of those in particular, those bars in particular, it really does look like everything is pretty equal right now, right? We've got 2 numbers here, 2 numbers here, 2 numbers here, and 2 numbers here. That is going to start to look a lot different when we take this data set and we move it to just a regular number line, but we're not quite there yet. Our next step is going to be to close the box. And what we're doing is we're taking from quartile 1, and just drawing a line right here from quartile 1 all the way to quartile 3, and we're closing the box. That's all we did. That box that I just filled in represents 50% of our data, right? So 25%, 25%, 25%, 25%, right? 50% of my data is represented here between quartile 1 and quartile 3. And all I did at this point was to close my box. Right, let's move on to the next one. Right, so now that my box is closed, I'm going to look back at my data, and now I need to draw the whiskers. And the whiskers are kind of the weirdest thing. They go out from quartile 1 and quartile 3 to the lowest portion of your data point to the highest portion of your data point. And somebody explained this to me once many years ago, and that it's almost like drawing the whiskers on the nose of a cat. Imagine this box is kind of the nose of that cat, and we want to draw the whiskers of that cat all the way out as far as we can go with our data point. So there's whisker 1, and there's whisker 2. So now we've got our box and we've got our whiskers. All right. So now we've got all of our information totally notated. And at this point, the next question that I would probably always give you is, what is your interquartile range? And if you have done like I did and wrote down all of this information up here, what is quartile 1, what is quartile 3, this gets really, really easy to kind of figure out as we go. So if we're looking at the information here, remember our range is the difference between the largest and the smallest number, but we're not talking about the range of our total data set. We're talking about our interquartile range. And so again, we're looking at the range between quartile 3, which is 8.5, and 5.5, which is our quartile 1. So here's 5.5. So some simple subtraction, right? We're going to line this up. 5 minus 5 is 0. Bring down my decimal. 8 minus 5 is 3. So my IQR, please forgive my awful writing, guys. My IQR is 3. That is what our interquartile range is going to be in this particular situation. Right. So our interquartile range is 3. I've got my lower quartile at 5.5. My median was 7.5. My upper quartile was 8.5. And our IQR was 3. But what I want you guys to kind of look at now is, again, the spread of the data. The spread of the data, again, still looks pretty even. So we're going to be moving on and we're going to look at why the spread of the data is even and how it changes. So with this, we're going to consider the data breakdown. Remember, when we're talking about a percentage, we're talking about something that is always 100%. We are representing 100% of our data with each one of these points. And each one of these quartiles, because we broke it down, finding that median, is 25% of our data. So I've got 25% between the 4 and the 5, 25% between 6 and 7, 25% between 8 and 8, and 25% between 9 and 12. Now this looks really even. There's 2 numbers per box. And so it does look like we have an even spread of 100%. But this chart here is really deceiving because it isn't exactly just a straight number line. I've got 2 number 8s, and then I also have a pretty big gap here between 9 and 12. So we are representing our data in 100%, but if we want to have an accurate view of our box and whisker plot, we're going to have to take this information now and we're going to have to plot it on a number line. And so that is what we're going to do. So again, I have a number line here. Again, we're going to consider our data breakdown. And our lower quartile was 5.5. So I'm going to draw my line roughly here at 5.5. Our median was 7.5. So again, that was between 7 and 8. My upper quartile was 8.5. So that's going to be right here. And already we can kind of see how this data has changed just a little bit. I'm going to close my box. My lower whisker was here at 4. And my upper whisker was all the way out here at 12. So now I've just redrawn my box plot. And remember, each one of these quartiles is representative of 25%. So I've got a much bigger spread now of data. It looks like there's much less data here and a whole lot more data right here. And that changed because of our original data points. So when we take this information and we plug it into a number line, we're going to get a very different picture than what we got before. Let's see. So I'm going to erase this and then I'm going to go back and I'm actually going to show you again what we had before so you guys can kind of see and compare the two. So before, remember, it was super even. And now we've got something that looks more like this, right? Very much not even. But again, I have my 25% here, my 25% here, 25 here, and 25 here, all totaling up to our 100% of the data. So the reason I'm hitting so hard on that 100% is because you will be given questions regarding how much of our data is represented in a specific portion. So if we look again and we note that this is quartile 1, quartile 2, that's an awful 2, quartile 3. I can ask you guys, okay, what percentage of the data is represented between quartile 1 and quartile 4? So if I'm looking at quartile 1 and wanting to consider all the data for quartile 4, well, let's find out what percentage of data that is. I've got 25% here, 25 here, and 25 here. So if my question to you was what percent is between quartile 1 and quartile 4, I've got 75% of my data, right? If my question to you is what percent of the data is represented between quartile 3 and quartile 1, again, at this point, it's just 50% of the data. So it's an equal spread. It just looks a little bit different.